All right, guys, welcome to FRQ, question type 7. We're going to revisit the rate in, rate out. So some common things to expect with these types of FRQs is a lot of times they'll want you to write an integral function to represent the whole. Sometimes they might want you to find a total in or a total out. A lot of times they want you to find when the total amount is increasing or decreasing. And sometimes they want you to find maxes and mins of the total amount, which I should probably put here. And in these problems, units and interpretations are important, so you want to be able to keep track of your units especially. Some questions may only have a rate in or only a rate out. So not all questions will have both a rate in and a rate out. Some will just have a rate in or some will have just a rate out. And that's pretty much the gist of it. So let's go ahead and start here. So question 1, fish enter a lake at a rate modeled by the function e given by this expression here. And then fish leave the lake at a rate modeled by the function L given by this equation here. And both E of t and L of t are measured in fish per hour. Pay attention to those units, where t is measured in hours since 6 a.m. And t equals 0 means 6 a.m. So for instance, t equals 1 would be 7, t equals 2 would be 8, and so on. And these equations are only valid on the interval from 0 to 8 hours. So after t equals 8 hours, the equations no longer apply. It also tells us here that at t equals 0, meaning 6 a.m., there are 100 fish in the lake at that time. All right. Now, before I start writing these, with a rate in and rate out question, it could be a time killer, but it could also help make a lot more sense of things if you take a moment to complete this chart. So we have a rate in, and that's the E function. And that's how fast the fish are entering the lake, and my units are in fishes per hour, right? And my rate out is L of t, and that's in fishes per hour fishes per hour also, and that is how quickly the fish are leaving the lake at any given point in time. So notice I'm going to put the function in there and the units. Now, the net rate of change is if you take how fast they're entering and subtract from that how fast they're leaving. And that's also in fishes per hour. Okay, so this tells you how quickly fish are entering, this tells you how quickly fish are leaving, and this just tells you how fast the total amount of fish in the lake is changing, right? So, I mean, let's say that they're coming in at 100 fish per hour, but they're leaving at 50 fish per hour. Well, 100 minus 50 means the overall net rate of change would be 50 fish per hour. Since they're coming in faster than they're leaving, overall, you're going to have a net increase, and so it's going to be increasing at a rate of 50 fish per hour, and that's what that means. So you have your rate in, you have your rate out, and you have your net rate. Now, when you integrate these functions, that tells you the total number of fish that are added into it over the time period from A to B. And that the answer there is just going to be fish. So if you were to integrate the rate E of t, the outcome will tell you how many fish came into the lake from t equals A to t equals B. So for instance, if you want to find out how many fish entered the lake from time 1 to time 5, you would put 1 here and 5 here and integrate that E function from 1 to 5, and that would tell you the total number of fish that actually entered the lake. And I want you to keep in mind, that has nothing to do with how many left. It's just telling you overall how many went in. Okay? So now, if you integrate the L function, something similar happens. This just tells you how many fish were lost over time. And so, once again, that's going to be fish. Now, when you integrate a rate, you lose the bottom factor. So, when I integrate fish per hour, which is what E is, when I integrate that, the hour goes away and you're just left with fish. Okay? Now, the net change in the amount over time would be if you take the net rate and integrate that. And what that would tell you is the total change in the number of fish that are present in the lake at any over some time period. So this tells you the total number of fish that went in, this tells you the total number of fish that came out, and this tells you the total change in the amount of fish over that time period. So we have our rates. This is how fast the fish are entering, this is how fast the fish are leaving, and this is the total rate of change of the number of fish in the lake at any time. This tells you how many fish entered on a time period. This tells you how many fish left on a time period. And this tells you the total change in the number of fish on that time period. Now we have one more thing, which is the number of fish formula, we'll call it. Or we'll call it the amount formula. Just to be more general. We'll call it the total amount formula. Okay. Now, in this case, it would mean this formula I'm about ready to write down would be a formula that can tell you the total number of fish at any given time. So how that works is you're going to have the starting amount. Better. It'll shift back. Starting amount. And you're going to add to that the net change in the amount. Okay? So, my starting number of fish, well, let's just say that F represents the number of fish at any given time t. The total number of fish at any given time t is going to be the starting number of fish, which is we're going to say is 0. Matter of fact, to be more general, we could say A, plus the integral from that starting time to whatever ending time you want, t, of the net change of the amount. So this first one here tells you how many fish you started with, and this tells you how many fish overall the lake had added or left to it overall on the time period. If you put those two things together, that'll tell you the total amount of fish at the given time you're interested in. And so there you go. Now, I'm talking a lot through this, but really, it doesn't take that long to fill out this chart and to have this chart in mind when you come across a rate in and rate out question. You know, it's nice to separate everything out, knowing what your rate in and rate out, net rate, total amount in, total amount out, total change, and then your formula. Having all that up front is really helpful. We could reference back to that later on. Now, I spent a long time talking about it, but you can actually fill it in pretty quick, and it's pretty useful. So I would encourage you to do it if you can. And notice also I include the units as I do it as well. All right. And by the way, down here, this will also have units of fish because that's a number of fish and that's a number of fish because it's from here. And so the total amount of fish there. But anyway, let's go ahead and start the problem. So the first question here is asking me to write an integral function, which we're going to call f, to represent the total number of fish in the lake in a given time t. Now, we've already done that on the little intro slide. That is a common question that they may ask you to do. So the total number of fish is equal to the starting number of fish, which is 100 in this case, plus the integral from the starting time, which is 0. Now, you got to be careful with that. They don't always start at a time of 0, but this one does. And then whatever variables here, that's what you're going to put up here. And then it's going to be the e function minus the L function. And that's a little function that can tell us the total number of fish at any given time. And so now another question they might ask, they're not going to ask both of these because it's kind of repetitive, but they'll ask one of them. Part B is just kind of like a step farther than this one. On part B, you just are going to plug 5 in. Now, they may ask you to interpret it, so I'll interpret it when I'm done. But basically, we need to plug this into our calculator. we're plugging 5 in for t, and we're going to see what we get. So, and 9 times out of 10, rate in, rate out questions are calculator based. So I can't even think of a time I've seen a rate in, rate out question that wasn't calculator based. So let's go ahead and go to our calculator here and see what we can do. So first of all, let's clear our calculator. We're going to go to y equals, we're going to enter our function. So my first function is 20 plus 15 sine of pi t over 6. Okay. Next function is the e function, the L function. That's 4 plus 2 to the 0.1 t squared. I've already forgotten it. 4 plus 2 . And there we go. All right. Now, we're going to go ahead and go back to our home screen, and now I'm going to type in this function that I had written up here earlier, 100 plus the integral from 0 to 5 of e minus L. Okay, so let's do that. So we have 100 plus math 9, 0 to 5, and then it's e, which I put under the y1, so you have to remember which one is which, and y2. And we get 223.163. 223.163. Now we want to interpret it. What does that mean? This means that at t equals 5, which by the way would be 11 a.m., because if 0 is 6, then 5 would be 11 a.m. So you could also say at 11 a.m. At t equals 5, there are 223 fish in the lake. Okay, so that's what that means, because the F formula basically just tells you how many fish there are. All right, so let's go ahead and move on to our next question. All right, so this part up here is the same. I haven't changed anything. The only thing that's different is A and B. So now A and B, once again, they're not going to ask both of these questions because they're too similar. Okay, but you may see one of these questions asked on your AP exam. This one says how many fish entered the lake and how many fish left the lake. Now they only want to know entered for this one, and on the second one they only want to know how many left. Now we had this little chart a while back. Let me recenter it here. And as you guys can see here, if you want to find the total number of fish that entered the lake, you're going to use that formula. And if you want to find the total number of fish that left the lake, you're going to use that formula. So it's helpful to have that little chart right up front so that we know exactly what to do. So for this one, it's going to be the integral from 0 to 8 of e. And the next one's going to be the integral from 0 to 8 of L. There's that. And once again, you're just going to punch these into your calculator and get your answers. Now, I think I'm going to go ahead and just skip the calculator work here because I think you guys know how to do it at this point, but that's the idea. All right, let's go ahead and move on to the next part. Same given information, but now we're going to ask a new question. This next question is saying, at what times on the interval from 0, we're not going to go from 0 to 24. I forgot to change that. We're just going to go from 0 to 8. At what times on the interval from 0 to 8 was the population of fish decreasing? All right, well, we have a function here, and it's f of x represents the total number of fish. We saw that on our very first question. We created this function that tells us the total number of fish. And we also know that the total number of fish, f of x, is decreasing when f prime of x is less than 0. Now, we saw also back on our very first question here that f of x is equal to 100 plus the integral from 0 to t of e minus L. Well, if I want to find out what f prime is, the 100 is going to go away because it's a constant. The integral is going to go away when you take the derivative of it, and the t is just going to drop down inside, and you're left with this. Now, as we said before, f prime, which is this, has to be less than 0, right? So that leaves us now with this next fact, that e of t minus L of t has to be less than 0. And if e of t minus L of t is less than 0, if I just add the L of t to both sides, then I'm going to get the fact that e of t is less than L of t. Now that doesn't, that's actually, there's a way that you could actually skip all of this and just jump straight to this conclusion, and I think that they would be okay with that. Having some technical issues at the moment. So let me say that again. So I think you can technically skip all of this and just go straight to this, because there's actually a way that makes sense. If the population of fish is decreasing, wouldn't that mean that the rate at which they're entering is less than the rate at which they're leaving? Or you could say the rate at which they're leaving is greater than the rate at which they're entering. But either way, it means the same thing. And vice versa, if they were asking on what interval is the fish increasing, then the inequality would be reversed. So you could just jump straight to this, and I think that they would give you credit for that. But this is a nice little explanation too. So f is the total number of fish. F is decreasing when its derivative is less than 0. The derivative of f is e of t minus L of t, so that would have to be less than 0. And by adding L of t, you get this. So either way is fine with me, whether you do the whole thing or just jump straight to this, it's fine. All right, that being said, let's go ahead and continue on with the rest of the problem. So we've gotten to this crucial matter here. We're looking for the place where e of t is less than L of t. Now on a graph, that would mean that e is under L on the graph. Because if e is less than L, then it would be underneath of it on the graph. So we need to look for where e is underneath of L on our graph. So let's go ahead and do that. We're going to go to our function, and we're going to go ahead and make sure our functions are still in there. They are. We're going to graph. Probably going to have to adjust our window a little bit here. I know that my t values are only going from 0 to 6. Now, as far as the y values, it looked like they were a little low. We don't need to go below 0. And let's go a little higher. Let's go up to maybe I know there was 100 fish. So let's go ahead, and actually one of our answers had 200 fish. So let's go ahead and just put 200 in here just to be safe. It was probably a little over the top, but there we go. All right. So now let's go ahead and trace here. So that's one thing you're going to want to do, is you're going to want to trace. And now we can see that blue line represents the entry function, the rate of change of entry, the rate at which the fishes are coming into the lake. The red line, if I just push the down arrow here, that's going to tell me the L function, the rate at which the fish are leaving. Now we're looking for where the E function is under the L, and it's not in the window, but I just remembered I made a mistake. We're not going from 0 to 6, we're going from 0 to 8. So let's go ahead and punch that out to 8, and let's regraph this now. There we go. Now, as you guys can see, from about here, at this value of t, all the way up to 8. So whatever this t value is here, I don't know, I'll put a question mark there, up to 8. The E function is below the L function. Okay, so I need to find out what this point is, and then from there I can write my interval. It's going to go from here to here. That's where E is less than L. Okay, so how do we find where they're intersecting? Well, hopefully we know how to do that. You're going to do second Calc 5. You're going to scroll to where they're intersecting, and you're going to push enter 3 times, and it's 6.204. So so these are probably the two crucial pieces of information that you really need to have on your paper to get credit for this problem. They need to see that you know that if the population of fish is decreasing, they need to see this at least. And to be safe, it might be good to demonstrate this as well. Just to kind of get it started. But definitely make sure you have that last one there. So they'll want to see that, and then the final answer. The rest of it's done on the calculator. You don't need to write that we're looking for where E is under L. They'll know that you know that just based on the answer you write here. So there's the idea, though. So that's how you can find where one of these integral functions that involve rate in, rate out are increasing or decreasing. All right, let's go ahead and take a look at our last question for this one. When did the population of fish reach its maximum? Now, as you guys know, this is going to be a candidates test. Now, the left side is always going to be whatever your input variable is. It's t. The right side, people struggle with that a little bit. You got to look at, what do I want to find? I want to maximize the population of fish, and that's the f function that we created back in step 1. Okay. Now, as you guys know, the candidates test, you always put in your first and your last, and then you're also going to put in here the critical values. And the critical values are anywhere where the derivative of this function equals 0. Now, we've already talked about this, though. The derivative of f is e of t minus L of t. And by the way, this should have been a t up here, not an x. Which means we're looking for where e of t equals L of t. And we've already done that too. That's where they cross. And we found that earlier. It's still on our calculator. Let me go back and look at it because I've forgotten what it was. But it was this point right here is where they cross, and that's 6.204. Okay, and so what we need to do now is we need to find f of 0. We need to find f of 6.204, and we also need to find f of 8. And then from there, we can figure out how many fish are in the lake at these candidates and see which one gives us the actual maximum value. Now, we already know f of 0 is 100 because that's the starting number of fish. But as for these other two, we're going to have to work it out. And the way we're going to work it out is the same way we worked out the second problem that we did today. Remember back on the very first slide, we did this one, right? Well, we're going to find f of 6.24 and f of 8 in the same way. And the way that you do that is take the starting number of fish and you add to it the integral from 0 to whatever that number is for e minus L. And we'll do the same thing here with this one. It's going to be 100 plus the integral from 0 to 8 of e minus L. And once again, those are going to be calculator-based questions. So let's go ahead and do those really quick. Go to our calculator. Oh, look, that's the last thing I entered, actually. That's nice. That saves me time. So to save time, I can just push second and entry, and it brings back the very last thing I typed in. And all I have to do is go back and replace the number with what I want, which is that. So there's one of them. And then second entry again. I'm just going to scroll back and replace that whole thing there with an 8. And then we'll delete the rest of those numbers there and push enter again, and that'll give me 8. So there's 235.015 fish. Don't really need to be too specific here, but I'll be 015. And then the last one, f of 8, we have 180.92. 180.92. Now for these questions, you do have to pay very close attention to what they're actually asking. Are they asking what the maximum number of fish is? Are they asking for the time when we reach the maximum number of fish? Or are they asking for both? In this question, they're just asking the time. So we would say the answer is at t equals 6.204. And this over here counts as your work. Okay, that's all you really need to show on these. Okay, so now if you hadn't already done it on the previous problem, it might be a good idea to show this as well. Oops. Show that you did know that f prime has to equal 0, right? In which case you would get the fact that that's where E equals L, and that's where you get your 6.204 from. So it might be nice to write this if you haven't already written that somewhere else on another problem on your paper. And as far as finding the values, it might be good to actually write out this part as well for both the 6.204 and also for the one with the 8. Now, once again, though, if you've already got those things somewhere else on your paper, like we did this also on number 1 of the FRQ, then you don't really necessarily have to do it again because you've already demonstrated that you know it. But you can do those. You could just show all your work to be safe. But the bare minimum, I would say, that you could possibly get away with would be the candidate's test and your final answer. But to be safe, just show as much work as you can. And that does it for our little presentation there. Be careful to pay attention to your units. Some questions only have a rate in or a rate out. And when that happens, let's say I only had a rate in. Well, then all of this stuff is now irrelevant. And this last piece here would just be, f of x is equal to the starting amount plus the integral of whatever was here, in this case, e. And that's it. It's not going to have two functions. Something to keep in mind, if you only have a rate out function, then what you're going to do is you are going to put a negative in here instead of a plus, because now the starting amount is losing a certain number of things. So if you had just the L in here, like if we never had fish entering the lake, but we only had fish leaving, then you would have starting amount minus the integral of L. Okay, so for rate out, you would subtract it, and for rate in, you add it. But like I said, a lot of these rate in, rate out questions just have both. And so in those cases, you just put plus and you put E minus L here, right? But that pretty much does it for our rate in, rate out notes. And hopefully that was helpful, and we'll see you guys in class.